Hey guys, this is Mr. Sal. We're going to look at the angle sum of a triangle. Thanks for watching. Don't forget to like, comment, and subscribe. I know the angle sum theorem for triangles. The sum of the interior angles of a triangle is always 180 degrees. I can present informal arguments to draw conclusions about the angle sum of a triangle, which we'll look at. So again, this is the objectives, or what we expect you to know by the end of the lesson. That the sum of the interior angles of a triangle is always 180 degrees, and then we should know that for informal arguments. So, the first thing we're going to do on this is just define some of this vocabulary, which may be new to us. Well, actually, we've seen some of it already. But this is going to be for a triangle. So we've talked about interior angles. Interior is on the inside, kind of like interior design is on the inside of your house. So interior angles would be like this red one, this red one, and this red one. Okay, all three of these are interior angles for a triangle. All right. So interior angles for a triangle, if we were to add all three of those up, we should always get 180. This is an acute triangle, not that it matters though, because if it were an obtuse one like this one, if we took the three angles again, to add them together, we should get 180 degrees. So the next couple weeks we're going to be working on a problem-solving strategy, such as understanding the problem. The first thing to understand a problem is reading it, and that's what we're going to do on this one. So, we're going to read this, and then we're going to see if there's any questions on what it's asking, so that we can understand what the heck it's trying to tell us. Let triangle ABC be given. On the ray from B to C, take a point D, so that C is between B and D. Through point C, draw a segment parallel to AB, as shown. Extend the segments AB and CE. Line AC is the transversal that intersects the parallel lines. All this does right there is it describes the figure that they gave us right there at the top. They essentially drew the figure for us and then described what they drew. So if we didn't have the figure right there at the top, we would have been able to draw it just from the words that they gave us. So part A, this one says name three interior angles of triangle ABC. This is going to work a little bit different than what you guys did in 7th grade, but I want you guys to try it. Take a moment with your partner and see if you can name all three interior angles of triangle ABC. Alright, so here's what I find from you guys at this point, because you guys just gotten out of 7th grade essentially, is we got this angle, and a lot of people, the blue one right there, would name this angle B. However, if that were the case, then we would need to identify how we would name this angle right here in purple. Now we got to be careful though, because if I call that angle C, then I've got to worry about this angle or this one. And just saying angle C, it could identify any one of those three. So we got to be more specific when we're naming angles. Alright, we could use prime marks if it was transformations that was creating those, but it was not. So we got to be careful. So the purple one, this angle in purple, would be angle ACB. Or if you wanted to, and it would be the same angle, it would be angle BCA. And it doesn't matter to me which one you guys write there. Wait. So here's how it works when naming the angles. Let's look at the blue one again. So I would start at A, and I've got to create that angle, so I would go to B, and then to C, and then I create that angle right there. So it would be named angle ABC, would be the blue one. Alright, this last angle up here at the top, can someone tell me the name of this angle? Angle CAB would be correct. So keep this in mind. We expect you guys to be able to name angles with the vertices like we've done right here. And it always includes three letters. Unless it's a diagram like the one we started out with where they numbered the angles. Then we can just use the numbers for those. Otherwise, we're looking at naming these using three letters. So part B, again, we're focusing on the reading here. Name the straight angle. Now, straight angles, you learned in 7th grade. So take 30 seconds with your partner and name the straight angle. All right, who can tell me the name of the straight angle, please? Now be careful when naming these. We got BCD. Since it is an angle, we do want to include that it's an angle with the angle symbol in front of it. So this would be read as angle BCD. Now part C. Part C, I'm going to read this. Pay close attention, all right? You guys need to ask if you have any questions about what it's asking. What kinds of angles are angle ABC and angle ECD? What does that mean about their measures? Take 1 minute with your partner and talk about those two angles and what that means about their measures. All right then. So here's the answer that we usually get, and let's identify these. I've got this blue angle, and then ECD would be this blue angle right here. So what I see from walking around with the classes is that most of you guys are putting acute angles on this, but that is 7th grade stuff. While these two are acute, which makes them less than 90 degrees, that's not really the answer we're looking for on this. So to describe this one, and we've seen this description before already, we would say that angles ABC and ECD are, so again, you guys have identified them as acute, but these ones are corresponding angles and equal because line AB is parallel to line EC. And that's how we should describe this. And you should have a full sentence on that thing. We would expect the answer to look like this on a test. Now before we look at part D, part B, it says that angle BCD, or we said that angle BCD, or we could say angle DCB, that's a straight angle. How many degrees are in that straight angle? 180 degrees, right? We need to remember that the straight angle is 180 degrees when we look at part E, I think. All right, part D says, what kinds of angles are angle BAC and angle ECA, which would be this green angle here? What does that mean about their measures? All right, take 1 minute and talk about that with your partners. So on this one, we got those two red lines, AB and EC, they're parallel. And so the transversal for this one is AC, which makes these two green angles, BAC and angle ECA, these would be alternate interior angles. And since the two lines are parallel, we know that they are equal. All right, we're going to look at E in a different way instead of using substitution on this stuff. So we've got this blue angle right here, and this blue angle. Then we've got this green angle here with this green angle. Then we've got this purple angle. I guess before we look at that though, let's kind of ignore this stuff right here. So just looking at these three angles, what kind of angle do these three make up? Very good. That's 180 degrees. So this is 180 degrees between these three angles. But let's look at the whole picture on this. Well, the angles are the same on this, right? For example, this is our green angle here, and this is our blue angle, which is the same as this angle in green. and this angle in blue. And the purple angle is just still the purple angle. So that shows the blue, green, and purple angles all make up 180 degrees. Not only on that line, but also on the interior of this triangle. That also gives us 180 degrees on the inside there. Now again, we've kind of proven this because of the angle relationships when these lines are parallel with the transversal. This is on the next page. The figure below shows parallel lines L1 and L2. Let M and N be transversals that intersect line 1 at points B and C, respectively, and L2 at point F as shown. Let A be a point on line 1 to the left of B, D be a point on line 1 to the right of C, G be a point on line 2 to the left of F, and E be a point on line 2 to the right of F. Part A, name the triangle in this figure. Take 30 seconds to do that with a neighbor or partner. So let's identify the points in this triangle. This is point B, this is point C, and this is point F. Now be careful because it's not enough just to say it's triangle BCF or to say that it's BCF. It needs to be indicated with a triangle in front of it, triangle BCF. Now if you order these differently, that's okay. You may have gotten one of these following ones. Any one of these 6 would work as a name for this triangle. Just know that some of your teachers in the future may tell you that this has to be in alphabetical order. However, I don't care. Name a straight angle that will be useful in proving that the sum of the measures of the interior angles of the triangle is 180. There's several that would work on this one. Okay. The straight angle. Since it's an angle, we should have three letters on this thing. GFE would work, but also angle ABC would work as well. Or DCB or EFG. Any of them would work. Alright, let's write our proof below. Okay, so we want to show that this is 180 degrees. Alright, here's what we know is that this interior angle of the triangle, angle BCF, is congruent to this angle, which I guess we can't really name because there's nowhere to put that angle there. Which means it's also equal to this angle. You know what, in fact we don't even need that one. Angle CFE is congruent to angle BCF because line 1 is parallel to line 2. And these are alternate interior angles. So that's the beginning of this proof because it only shows one angle right there. Now we're not so concerned about angle BFC. However, we are kind of concerned about this angle right there, which is alternate interior with angle CBF as well. Now once again we've shown that these 2 green angles are the same and the 2 red angles are the same. So these 3 rather, are 180 degrees. But also everything on the inside of this triangle are the same angles, which makes this 180 degrees as well. Alright, so I'll finish that last part. So there we go. We got those 2 green angles which are the same. And the triangle includes angle BFG as well as that straight angle, which means that this is 180 degrees, as well as the 3 interior angles of the triangle. So our proof could get quite long if we wanted it to, and it could look something like this, but I like the way that we did it better. In the diagram, line AB is parallel to line CD, which is going to create unique relationships. That is, line AB is parallel to line CD. The measure of angle ABC is 28 degrees, which is shown. And the measure of angle EDC is 42 degrees, which is shown. Find the measure of angle CED and explain why you are correct by presenting an informal argument that uses the angle sum of a triangle. Okay. And the two lines are parallel. So we'll write that in. Alright, so we know then that angle ECD is 28 degrees. And we already got this angle at 42 degrees, which is nice. So if we wanted to figure out this third angle, angle CED, then all we got to do is take these two angles at 28 degrees and 48 degrees. And when we add these together, we get 76 degrees.
Yeah.
But we're going to take that off of 180 minus those 76 degrees, which will give us the green angle, because we know all three have to add up to 180. So this gives us 104 degrees. So we would write this, we could write really long. That's okay, we'll write it in. So angle ECD and angle EDC are the two other interior angles of the triangle. So the third one would just be the remainder after taking off or subtracting those two angles from the 180. And we get 104 degrees, which we already had.
We don't go to
In this diagram, in the diagram below, line AB is parallel to line CD. That is, line AB is parallel to line CD. The measure of angle ABE is 38 degrees, and the measure of angle EDC is 16 degrees. Find the measure of angle BED. Explain why you are correct by presenting an informal argument that uses the angle sum of a triangle, which is kind of what we did on that last problem. So on this one, we'll work it the same way.
Wait, what does my CD?
Alright, so first off, that 38 degree angle here in red is equal to this angle ECD, because they're alternate interior angles, and the two lines are parallel, which is what it said in the beginning. So let's write the answer to that part. That takes care of that part. We know these alternate interior angles are equal because those two lines are parallel. Next, what we'll do is find the measure of this angle, angle CED, which is one of the hints it gave you on your paper, which is just using the angle sum of a triangle to figure this one out. So we know the angle ECD is 38 degrees there in red, because it's equal to this red angle at the top. So what we're going to do is add those two together. Angle ECD plus angle EDC would be 38 plus 16. So those two angles added together give us 54 degrees. Now we know that if we add that third angle in green there, we would get 180 degrees. So if we subtract these 54 degrees off of 180, we'll have angle CED. Alright, so angle CED is 126 degrees there in green. And now we want to figure out the measure of angle BED, which is the actual thing we're trying to find on this one. So we know that angle CED and angle BED, in 7th grade you guys learned that these are supplementary, or that these make a straight angle. So that means that combined they'd be 180 degrees. So we're going to take off 126 from 180 to figure out that purple angle there. Alright, so 180 minus 126 is 54 degrees, which gives us angle BED, which is that purple angle. So this is angle BED at 54 degrees. And that's the answer we wanted on that. So we used the angle sum of triangles to figure this one out. In the next section, we'll be doing this a little bit differently to find this angle, but for now that will work. In the diagram below, line AB is parallel to line CD. The measure of angle ABE is 56 degrees. Let's go ahead and put that in now. I'll do it in red. ABE, 56 degrees. And the measure of angle EDC is 22 degrees. So that's this angle here, 22 degrees. Find the measure of angle BED. Explain why you're correct by presenting an informal argument that uses the angle sum of a triangle. Okay. Alright, to do this one, we'll do it the same way that we did those other ones actually. I'm actually going to extend this line and I'll call this intersection A, B, C, D, E. We'll call it F. Alright, so if that's the case, this angle is congruent to the purple angle because it's alternate interior. And then we can solve for this green angle here by using the angle sum of triangles. So the 22 degrees plus the 56 degrees will tell us how much those two combined are at 78 degrees. Then all I need to do is take 180 and subtract those 78 degrees, which means that green angle is 102 degrees right here. And this makes a straight angle with this blue angle right here. So to figure out the blue one, all I got to do is take 180 and subtract 102 degrees. Then I got my blue angle at 78 degrees. So this angle, 78 degrees. Angle BED equals 78 degrees. Alright, take a moment with your partner and answer this question. What is the measure of angle ACB? On this one, we know that all three angles have to add up to 180 degrees. These two added together, 83 degrees and 64 degrees, gives us 147 degrees. But added to that red angle, we would get 180. So we're just going to take 180 degrees and subtract it from 147. And that makes this last angle 33 degrees. Don't forget to label this in degrees on a test if you want full credit anyways. 33 degrees. Now we may ask, how do we know it's 33 degrees? Because if I were to take these three angles, 33 degrees, that's right, 83 degrees and 64 degrees, they would add up to 180 degrees, which we know now all three interior angles of a triangle have to add up to 180 degrees. What is the measure of angle EFD? So we know these three angles added together have to equal 180. So we're looking for this angle EFD in red there. So once again, I'm going to take that 101 degree angle and add it to the 40 degree angle. That's 141. Now if I add the angle EFD, I should get 180 degrees. So all I'm going to do for that is I'm going to take 180 and subtract the 141, which will tell me how much is left. And that's that red angle at 39 degrees. So this angle is 39 degrees. On this one, we're going to show it a little bit different. We got those three angles. Angle HIG, which is the one we don't know, right here in red. And we got another interior angle, angle IGH. And we got another angle IHG. And these three added together will always equal 180 because they're the interior angles of the triangle, all three of them. Well, we know two of these values. We know IGH right here is at 14 degrees. And also angle IHG, which is at 154 degrees. Now we don't know the measure of angle HIG, but we know if we add these together, we'll still get 180. So this just becomes an equation that we need to solve. So I'm going to combine 14 and 154. So angle HIG plus 168 degrees would be 180 degrees. And then to solve for angle HIG, they're in blue now, we would just subtract this 168 degrees in this equation. And then we get angle HIG is equal to 12 degrees. Take 1 minute with your partner and figure out what the measure of angle ABC is. Since we see that these are all the same, I guess, symbol for all three of these angles, we know that they're all the same because, again, they're represented by the same letter, I guess, in this case. So really what we're going to do is we're going to take 180 and we're going to divide it by 3. And that will tell us how big the angle is, which is 60 degrees. Now we know this is 60 degrees because if this angle is 60 degrees, then this one would be as well. That's right. And all three of them add up to 180. That's very good. This one wants the measure of angle EFD, which is this angle in red here. Now they didn't tell us specifically or gave us the number for this, but since it's boxed right there, we know this angle is 90 degrees. So if we take the 57 degree angle and add it to 90 degrees, then the two combined would give us 147 degrees. Well, this is three angles, so we're going to take 180 and subtract that 147.
33.
And that will give us the red angle there at 33 degrees.
Dude, Dad, I did that.
What?
Now again, we can check by saying 33 plus 57 plus 90, does it equal 180? And it does, so we know that we did that right. In the diagram, lines 1 and line 2 are parallel. Transversals R and S intersect both lines at the points shown below. Determine the measure of angle JMK, and we'll explain. All right, angle JMK is this angle, which is very nice. Here's what we know is line 1 and line 2 are parallel, so this angle at 39 degrees would be the same as this angle at 39 degrees, because they are corresponding. Okay, if that's 39 degrees, then this whole angle right here in purple would be the 72 degree angle plus the 39 degree angle, which appears to be 111 degrees. Now the red angle would be what's left over from 180 degrees because they both, all three of them, make up this straight angle right here. So we're going to take the 180 and subtract the 111, and that gives us 69 degrees right there. This angle is at 69 degrees.